This is not the webcast.
Yeah.
That was not part of it.
All right, everybody, welcome to today's Anti-Siphon Anti-Cast. We got Cory with us here. If you are not speaking or participating during the webcast, please go ahead and kill your cameras and microphones at this time. Cory, thank you so much for joining us today. You're going to be talking about Kubernetes. I've heard of Kubernetes.
Yep.
I'm not quite sure what it does, which is why I'm here to learn today.
Yeah.
So Cory, thank you so much for joining us. And at the end, we'll try to see what kind of questions there are. We might interrupt you if there's a question that we get from a whole lot of people where they're they're confused. And so, but you can join us on Discord. Discord is the easiest way to get the community to help answer your questions. You can always ask those questions inside Zoom if you want to. But for the most part, Cory, it's all yours. We'll be here in case there's any technical problems, but for the most part, it's all yours, sir.
All right. Thank you. Thanks for the introduction. So I'm Cory Sabol. I'm a senior security consultant, securities, and I'm going to talk a little bit about Kubernetes today. And just we're going to take a attacker-centric perspective here. We'll just dive in. And so we'll start with, this is about me. If you get a copy of the slides, you'll be able to follow me on social media, or, you can reach out via email if you have questions, anything like that. But let's just dive in and let's talk about a little bit of background, right? A little bit of background knowledge so that we can kind of understand what Kubernetes is and what purpose it serves. So to do that, we need to understand containers. And, I've got my obligatory, shipping container image here. Because that's sort of the imagery that I often see associated with containers. Although I should probably replace this with like plastic food containers or something. That'd be a little funnier. So what is a container, first of all, right? If we take the definition from the Kubernetes website, right, we see that a container is a lightweight and portable executable image that contains software and all of its dependencies. Right, that explains it, right, at a high level what a container is, right? That doesn't give us the details of what it is, but essentially anything that kind of meets that definition, you could consider a container, right? So we have that concept of lightweight. Ideally, right, a container should be pretty lightweight, right? It's not running a full operating system. It's running kind of the file system that, processes might need, different binaries that they may need, things of that nature, right? They are intended to provide isolation. So one of the core features of a container is to provide process isolation, right? To isolate software, either, on the network level, IPC inter-process communication level, process ID level, file system level, right? There's all this different, these different pieces of isolation, like resource isolation, right? So like Docker, or really the container runtime standard, leverages Linux C groups to restrict containers access to CPU and RAM and other such resources, right? So that's a form of isolation as well. And then containers are intended to be reproducible. That could be either through the, like, for example, Docker file, which is pretty much the most common way to specify a container image and how it should be built, or through the image itself, right? You could take a pre-built container image and, in theory, deploy that to any system that's able to run the container runtime, such as Docker or Containerd, or even Run C is another one. That is able to run that software, right? And in theory, you could deploy your container image to that, and it should work, right? So it should get rid of that works on my machine, issue. And I think usually it does. But again, also containers introduce their own complexities, right? And kind of an important notes here too about containers. This isn't, absolutes, avoid absolutes. But for the most part, containers are going to share the host kernel and have their resources managed by the host kernel. The share the host kernel is a really interesting one, because that means that if the kernel that's running of the host system that is running the container runtime has kernel vulnerabilities, those can be exploited from within a container. And So that's a pretty common way to do a container escape, but it's not as reliable, right? Because it depends on that container being ran on a system that is vulnerable. Something in my container specific class and my upcoming Kubernetes class we'll look at is loading malicious kernel modules into the host kernel from within a container so that we can escape. So we'll go through and we'll compile a Linux kernel module that is a reverse shell and load that into the host kernel from inside the container, and then catch that reverse shell and compromise the host as one escape method. Okay, so let's talk about container orchestration, right? So Kubernetes is a container orchestrator, right? Kubernetes itself isn't a container runtime. It leverages containers and container runtimes to do a lot of stuff that it turns out is really useful to do with containers, but it's kind of complicated and difficult, right? So a container orchestrator is a system which is responsible for the various aspects of managing complex containerized deployments. So the life cycle of the containers, right? How long should they run? Should they be started back up if they crash, right? How many times should, if a container encounters a crash, how many times should it be restarted? Things of that nature. Deployment. So where should this container run, right? What sort of access should be allowed to it, right? Should it be exposed on a port directly on a Kubernetes node itself? Generally, that's a bad idea. Or should it, have a service that's associated with like a load balancer, and so traffic can be load balanced to that container? And scaling is another big one that a container orchestrator manages, which is, right, mostly that's going to be horizontal scaling. So do we need more of a container, basically, right? Or less? And you can set things up to sort of dynamically do that, or manually do that sort of thing. But those are, I think, the big kind of three, use cases of a container orchestrator. So these are really useful in like complex CI/CD pipelines, right? If you have complicated microservices architected application stack, right? There's a lot of buzzwords there. You can specify all of that as a set of, Kubernetes resources. Usually it's going to be a deployment, and you can specify all the different kind of ways that needs to be, deployed and scaled out and accessed in the cluster. And it's very declarative. So you give Kubernetes that specification, and it handles grabbing the images that you specified, starting them up, and, all of that good stuff, right? Another nice thing about being able to specify your deployment and lifecycle and scaling in YAML is that this kind of falls into that infrastructure as code category, right? So this allows us to do things like version control it, detect configuration drift pretty easily, right? And run like static analysis on the configurations, right, to detect insecure configurations or deployments before it's deployed, which is generally what we want. I mean, I'm a penetration tester, the majority of the time, so I do want to hack stuff, but ultimately I want my job to be more difficult. So, right, that's kind of a good thing there. So we already talked about Kubernetes, but within the context of, what is a container orchestrator? But Kubernetes itself, often abbreviated KATES or K8S, however you want to say it. It doesn't matter. You could pronounce it Kubernetes if you want to. Who cares? But I think it's Kubernetes. I'm not entirely sure though. That's an ongoing joke in the Kubernetes community too, if you weren't aware. But it's an open source container orchestration system that's responsible for providing those things we just discussed, but a little bit more as well, right? So automated application deployments, application scaling, automated application management, automated container lifecycle management, health management, so health checks and things like that. And then on top of all of that stuff, Kubernetes also has the ability to manage secrets, that, environment variables, and all of this other stuff that containers may need to be able to run. You have the concept of like role-based access control within Kubernetes, which is a big, sticking point in terms of securing a cluster. Users, you have service accounts, it keeps going, right? There's all kinds of things, right? And also, apparently, the word Kubernetes comes from the Greek word for helmsman. So if you've messed with containers and container technology and stuff, you know that it's always kind of had this nautical theme going on for a long time. And Kubernetes in particular has like the logo, which is the wheel of a ship. So it kind of makes sense, like helmsman, it's sort of guiding the ship in a way or something like that. I guess is what they're going for. So before we start talking about, the good stuff, I just want to define a few terms for everyone. Right, this may be a review. It may be new, but these are words I might just throw around, right? So it's useful to maybe know what they mean. So we have cluster, right? Which is a set of machines running containers, right? And so then we have node, which is a machine in the cluster. So the nodes make up the cluster, right? A node doesn't have to be like a bare metal machine either, right? It could be, but it can also be a virtual machine or a container itself. Often for a lot of my labs, if you were here for the pre-show banter, and we were talking about labs and building classes, one of the things I did for a long time was I ran Kubernetes inside of Docker. So I was running the Docker images inside of Docker. It starts to get a little weird, but at the time for some of the certain labs, that's what I had to do. So yeah, it could also be a container. And then we have the concept of a pod. So a pod is just a set of running containers on a cluster, right? And they don't have to be the same container either. They're just containers that are logically kind of related in some way, right? And deployed at the same time, right? So they're a part of that same pod, right? Which isn't that what like a group of whales is called? A pod of whales or something? I could be wrong, but that sounds right. So anyways, then we have deployment, which is an API object, which manages a replicated application. So in Kubernetes, everything's API driven, REST API driven in particular. And so you have the concept of API objects, right? And these are just like data classes, right? Specifiers. That's what I mean when I say API object, right? It's just some kind of data container in a way that tells the API what you want, what to do, or really what you want, and it figures out how to do it. So deployment, API object for managing a replicated application, very useful. We will look at a deployment as part of our demo, and I'll kind of map that to the sections that we'll talk about here in a second. And then we have the concept of a service. This is an API object which describes how to access applications. And then namespaces. Namespaces are something I will harp on a lot in my full courses because they're really useful, particularly for Kubernetes defense, for hardening a cluster. They're not a security control themselves, but a lot of security controls that work and are really effective within Kubernetes operate off of namespaces. So I talk about those a lot. But what namespaces are they're virtual clusters in the same physical cluster, so to speak. So you think of it as you have a bunch of resources in your cluster, and they're all related in some logical manner, right? You get to choose as the administrator of the cluster how they're related. It could be you have a continuous integration. You have a set of services that are all responsible for your application's continuous integration, right? So what you would want to do is take all of those resources in the cluster and assign them to the namespace of continuous integration. And so now logically those form a continuous integration cluster within the main cluster, and it'll get its own namespace. It'll get its own secrets assigned to it and its own roles and stuff. And so, yeah, that lets you start to key a lot of organization and other security controls off of it. All right. So that's a whirlwind tour of what containers and Kubernetes are. So we'll move on to what this webinar is really about. Talking about actually I need to move this Zoom control bar real quickly. So in a lot of my content, I talk about the Kubernetes or containers attack matrix. And this was developed in conjunction with Microsoft. And recently, I mean, it's like almost 3 years ago now at this point. In 2021, in 2020, they released the initial version of this matrix. And then in 2021, they released an updated one, kind of changed it from being specific to Kubernetes. In the way they named it, they called it containers attack matrix instead, even though it really still focuses on Kubernetes. The concepts could apply to any, I think, container orchestration system, although you're basically just going to use Kubernetes. Like, it's the dominant thing. A lot of other sort of similar projects have, been swallowed or killed by Kubernetes over the last 6 or 7 years, maybe. So it's sort of the dominant thing for doing this. But we'll go through and we won't talk about every single thing in this matrix. We don't got enough time for that. But we'll hit some of the highlights, and I'll kind of summarize what some of these columns are about, and sort of summarize what the common methods there and the motivation behind it, right? But we have things like initial access, execution, persistence, right? Like, if you're familiar with the kind of normal MITRE attack matrix, right? The MITRE attack framework. This is the same thing, but mapped to Kubernetes. And this just highlights the differences between the original version and the new version, right? Some things have been removed because they've become less common. And then some things have been added because, right, they've been observed as being more common. Side note, one of the reasons this was developed in tandem with Microsoft is, right, they run Azure, and Azure runs AKS, so Azure Kubernetes Service. And when they developed this initially, they basically used a bunch of data from AKS to kind of see, like, what are we seeing? What are we seeing threat actors do, right? How do we threat model this, and how do we then map it to this matrix? But yeah, we'll dive into some of this stuff. So we'll talk about initial access, right? What's the motivation? Gain entry into the Kubernetes cluster, right? These are just tactics or techniques that we can use to gain entry into a Kubernetes cluster. Whenever I'm penetration testing a Kubernetes cluster, if it's more of a black box test, this is probably very difficult, right? I'm going to need either to, and I don't really ever run into this situation. Most of the time for me, it's a gray box or even white box type of test, which I think is the most effective way to pen test a Kubernetes cluster, by the way. Because for the most part, if you don't have some credentials you've compromised, right, as a part of your engagement to access the cluster, or there's not like an application vulnerability, remote code execution really, or something, or maybe SSRF could get you around in the cluster a little bit. You're kind of going to be just stuck, right? Because from the outside, Kubernetes really just looks like pretty much any other external network attack surface. So you have to have those kind of same ways in, and that's why I find the gray box testing or white box testing to be best, because it's right, give me some credentials or let me deploy a container into the cluster as well, so we can also test from an assumed compromise as well, and see how how the cluster itself is being administrated and hardened. So it's sort of the same thing I would do with like a network penetration test, right? Here, plug this box in on your network, trust me, right? I'm a professional and will attack it from the outside, but we'll also assume a compromised workstation. It's kind of analogous to that in my head, right? So if some of you are coming from like a more network testing background or something, right? I often model a Kubernetes pen test in my head, sort of like a network penetration test, but honestly, more rigid. There's a lot less wiggle room. And so, yeah. So then we'll move on to execution, right? So the motivation of execution, right, is we want to execute code or commands or something within a Kubernetes environment. With this matrix too, with any kind of framework that tries to classify security vulnerabilities, I find, right, there's always overlap. You often aren't going to be able to classify something in like one discrete column or something, right? There's usually overlap and it's kind of a little more messy, right? So for example, if we had an application vulnerability that allowed us to execute code in its container, well, that would fall under, execution as well as initial access. That might be our initial way into the cluster as well, right? But the common tactics for this, right, is assuming that you have some credentials that allow you to execute commands in running containers. This is a common way to get into the cluster and start, trying to access secrets or data or pivot and, escape to the host system, to one of the host nodes, is execing into a running container. Another common one, this is probably the most common route for me on a pen test, is just a new container, finding some way to be able to deploy a container to the cluster. Potentially gives me a lot of possibilities for what I can now do. And that's what we'll look at in the demo. We'll deploy a container that lets us, escape to the host node operating system and do whatever we want with that, backdoor it or whatever, right? That is then now kind of a new phase of the pen test. Application exploit, right? We also looked at that as an initial access vector. Sidecar injection. Can we deploy a new container, but as a sidecar to something? Which, by the way, a sidecar container is a type of container that runs alongside of the main workload, right? So it's not the main service that's meant to be accessed. It's doing some sort of meta processing, or oftentimes it's for like logs, we're starting to see a lot more Kubernetes / container runtime security products. Often those run as a sidecar, right? They'll often deploy a sidecar along with your workloads where they can monitor system calls and things of that nature. And then, pipe that off to some dashboard for alerting. Then we have the concept of persistence. And so persistence is, right, maintaining access. So we want to either create new privileged roles or users within the cluster that let us do, something we couldn't before, alter the cluster's configurations in some way that maybe grant us, maintained access to the cluster. We could deploy malicious pods that re-compromise the cluster. So this could be like daemon sets is a thing that API has, which those will trigger anytime like a new node is joined to the cluster. So if you think about it like that, you could create a malicious container that runs in a daemon set that compromises the node host. So every time a new node is joined to the cluster, you're automatically gaining access to it, right? So you're establishing further access sort of automatically. Kubernetes also has cron jobs. It has this, and this is different from, right, like a Linux or, Nix. Cron job works with the same kind of like pattern specifier though, but it specifically has an API object that is a cron job that lets you schedule like a deployment or a job or something of that nature. So you could use cron jobs to kind of maintain access. Writable host path mounts, which we'll see a lot. That's kind of that's the old reliable, I think, right, with attacking Kubernetes. This is something I always look to do, like right out of the gate on a pen test, is can I deploy a container with a writable host path mount, right? Because now I can write files to the host. You could also have a malicious admission controller, right? Kubernetes has the concept of admission controllers, which are software that run before the API actually admits the changes that are trying to be applied to the cluster. So admission controllers can run on specific objects or all of them. And it's just doing some kind of check. One example off the top of my head is implementing image signing and image signature validation, right? So there's the concept in containers of signed images. Kubernetes doesn't have a native way to validate those, but there are third-party admission controllers which can validate those signatures. But if you think about, there's potentially sensitive information coming in these API objects as well as things are being deployed and changed. So a malicious admission controller could be exfiltrating that, stealing credentials to kind of maintain access, right? All kinds of things. Then we have privilege escalation, right? Which is gaining higher privileges, right? These don't necessarily go in order either of the way things might happen. I mean, initial access kind of needs to happen first, but once we get into the cluster in some way, we could also potentially achieve, our persistence or our execution through privilege escalation that by exploiting role-based access controls. Something I've seen many times is, so Kubernetes has the concept of a default namespace, which gets a default service account. So every container deployed in that default namespace is assigned the default service account. And something I've seen many times is new permissions have been assigned to that default service account, which I really recommend against, because now you're potentially, however, much privileges you've given it, you're giving every container now that set of privileges, and you're increasing that attack surface, right? And so what I've been able to do in the past is get into a container, and while it only had the default service account, that default service account had permissions in a roundabout way to deploy new pods. And so I was able to abuse that to deploy a new pod that had a host path mount that let me escape to the host of the node. So, right, it's the concept of following least permissions, right? You want to have distinct service accounts with only the minimal permissions needed for whatever that service account needs to perform. And don't modify the default service account, because it's by default, it's fairly restricted. There's pretty much nothing I would be able to pivot around and do with just the, out of the box default service account. In terms of abusing role-based access controls, right? I may be able to attack a vulnerable service that's in the cluster or something. You also have container escape techniques. We could consider these privilege escalation as well as pivoting. So host paths, kernel modules, kernel exploits. And those are really the main ones. There's a lot of tricky combinations of container capabilities that we can see as well pop up. But those get a little complicated because there's a lot of capabilities, and the way they all interact with each other is kind of interesting, and I wouldn't say impossible to enumerate, but it would be a big matrix or something probably. And then accessing cloud resources is another technique. If we think about where we're most commonly seeing Kubernetes these days, it is in one of primarily one of the major cloud providers hosted Kubernetes services. So you have AWS, what is it? It's AWS's, I'm forgetting the name of it for some reason. Pardon me, EKS, Elastic Kubernetes Service. Azure's AKS, Azure Kubernetes Service, and then Google Compute Platform's GKE, which is Google Kubernetes Engine, right? Well, most of these cloud services, right, they have interesting metadata API endpoints and stuff, particularly for, you're running a VM like an EC2 has the EC2 metadata endpoint. So if we compromise a container and we know it's running on a node that is, a part of these services, or it's like an EC2, one of the things to try to do is to access those cloud resources, access those endpoints, see if we can pull cloud credentials and pivot into other cloud resources or something of that nature. There's the concept of defense evasion as well, right? So that is staying hidden. Kubernetes has that as well, right? Being stealthy, right? Really, it's to avoid detection and maintain a low profile in the cluster. Kind of the common tactics for that are if disabling or altering logs or monitoring tools, disabling them, changing what they're, changing their configuration, using stealthy and less common attack vectors, like one that I labbed out that wasn't getting detected in a lab environment was loading a malicious kernel module under the host into the nodes Linux kernel. The interactions with the kernel weren't detected, but in this case, the system I was using was employing container image drift detection, which is a really fantastic way to just detect suspicious activity in containers. This is a side note, because what that does is that detects when like a new file has become present in the container that was not a part of the original image, right? And in most cases, that's going to be suspicious. There's probably some kind of tricky way I could come up with, or somebody else has already figured out, of how to like load a kernel module from memory only without creating any files on the system. That's probably something I need to look into, but right, using these just less common attack vectors and trying to stay under the radar there. Employing rootkits or other evasion tools. Again, this is kind of that kernel module type thing. Can we do something to the kernel of the host node to just sort of fly under the radar? We have credential access. This is stealing secrets, right? Kubernetes maintains a store of secrets that is not encrypted, by the way. You need to implement third-party tooling to encrypt those secrets at rest. Like HashiCorp has Vault, and I think what is it? No, I'm blanking on the name. There was another one I was thinking of, but it is eluded me. Access the container service account. We probably won't see this here, but one of the things I mentioned, how every container gets the default service account associated with it, or when it's deployed, you can specify a service account to use. What Kubernetes does is it injects a JSON web token into the container and the file system by default. So that token that represents that container service account is present in the container. And accessing that is, in my experience, the main way to abuse configuration issues in overly privileged roles, right? So we get a code execution, or we get like a file read vulnerability or local file include or something like that in an application that's running. First thing I'm doing is trying to read that service account token so I can pull that back and try to figure out what it's capable of. And then I can use that token with the Kubernetes command line tool to now interact with the Kubernetes API as that service account, right? So if it's capable of like deploying pods or modifying deployments or something wacky like that, or even just reading secrets, I'm going to be able to do that. There could be application credentials and configuration files, which you can read from the API. You can read the configuration that was used to deploy things. And again, a malicious admission controller, right? Because an admission controller, if you have the ability to deploy that, again, is intercepting those interactions with the API. So there's a lot of possibility there with that. And we'll talk about discovery, right? We're almost to the demo. I think I'm going a little fast, but that's good. They give us time to talk about things as well. So we'll talk about discovery, which is the concept of right. We're enumerating the cluster's nodes and pods. Mainly, this is going to be from within inside the cluster, right? And when I say within inside the cluster, that means either we have a container in the cluster that we're running code or commands within, or we have credentials that allow us to interact with the cluster using, the administrative tooling. So kube control is the command line tool, the main one to use, sort of the default one, right? There's other tools out there that you can use, but I just use kube control. In fact, kube control is one of the first things I try to infiltrate into a cluster when I get command execution in a container. Because it just makes it easier to then interact with the API from inside the cluster, right? I can infiltrate that binary, tell it to use the service account token of the container I'm in, and it'll automatically pick up from the container's environment variables the IP address, the internal IP address of the Kubernetes API, right? So I infiltrate that in and save myself a lot of trouble. Whereas like when I first started doing this stuff, I wrote my own really terrible tool in Go to sort of do all of this mapping and whatnot. And it was awful and I didn't want to maintain it. And then I was like, wait a minute, I can just use the official tool. And so that's what I did. It could also be mapping the cluster network and services too. So Kubernetes is also running, it's a network, right, with services running on it. So there's, again, some of that analogous, you know, some of the tactics that we would use on like an internal network penetration test apply here as well. Can I like infiltrate nmap into a container and, you know, scan the internal network? Maybe I don't have a service account token that lets me do anything, but I still want to look and see if I can talk to these other services that are running inside that container or inside that cluster network. Maybe one of them's vulnerable or has a weird API that is trusting the other microservices on the internal network, right? You see that a lot on internal networks, right? We say, oh, we can just trust this other service, but you know, that's a dangerous road to go down. We want to think about defense in depth. So, right, trying to map those, or maybe I have access to like a scripting runtime and I can kind of, you know, build my own quick and dirty little like host detection scanner or port scanner or something of that nature, right? And then again, I'm trying to identify roles and permissions. So if there's a service account token in there, I want to grab that. Maybe it has permission to read about the other roles that are present in the cluster. So I would want to read that as well. Yeah, basically just doing kind of want to, it's like reconnaissance in a way. It's not quite reconnaissance, but we have assumed some kind of access and we're kind of trying to get, you know, figure out what's out there. What's the, you know, what's our, you know, to identify our next move. Or in a lot of cases too, when I conduct pen tests, identify that really there's nowhere for me to move to. I mean, I'm seeing more and more clusters that are very hardened in a lot of ways. That's good to see again, right? I want to see ultimately, even though I like to pull off sick hacks, I want to see my job get more difficult, which is another motivation for, you know, teaching classes and doing training. And then we'll talk about, right, the concept of lateral movement, right? Again, we see accessing cloud resources, right? So there's, again, like I said, there's a lot of overlap here, right? So accessing cloud resources could result in some form of lateral movement. Oops, get rid of the chat there. It could result in some form of lateral movement. Utilizing the container service account, we see that again, that's a very common one, right? Could move laterally into another container or deploying. Technically, if we deploy another container, that's also a lateral movement from where we were contextually to a new context within the cluster, right? We could exploit the cluster's internal networking in some way. Maybe there's two services that are sending, you know, credential information, you know, HTTP requests or traffic that has sensitive information in it. And they're not utilizing HTTPS inside the cluster, right? Because again, it's assuming that it's not going to be sniffed. Well, if we're on that same internal network, that same adapter in a container, we can potentially, depending on a lot of factors, sniff that traffic. Maybe there's something sensitive in there that will allow us to move laterally, or just by virtue of being able to send our own traffic to a service, we might be able to do something and exploit something. One of the examples I run in my classes is we have a vulnerable application that's vulnerable to SSRF, and internally to the cluster network, there's a Jenkins service in a different namespace for doing CI/CD. Jenkins by default is pretty insecure and lets you like execute code unauthorized, right? So we can, in that example, use the SSRF to then move laterally by executing Groovy code against this Jenkins service to either get a reverse shell on it or, for example, read its service account token, and then use that service account token because it's a CI/CD account token. It makes sense that it could modify deployments, right? So take that, modify a deployment to then get, you know, actual command execution inside the cluster on a different, or deploy our own, you know, container with a host path mount to then escape to the node itself to, you know, break out of the container context. Yeah. And then again, we also see the same, right? Writable host path mount, moving laterally onto the host, container escapes, right? So kernel modules, kernel exploits, risky permissions or risky container capabilities. Again, those also allow us to move laterally to the host in this case. Okay. So we're gonna do a demo here. I have the payload that I'm going to use in the slides as well. So you'll have this. You'll probably have to change, the reverse shell IP and port or to whatever you use. But the way I'm going to lab this out today is I'm just running. And by the way, definitely let me know. I think the text is big enough. But if it's troublesome to see, just let us know. So the way I'm labbing this out today is I am running a local Kubernetes tool called Rancher Desktop. It's handy. It's just running. It's just a quick, easy way to set up Kubernetes on your local machine and run a distribution of it. I think it uses K3S behind the scenes to just quickly set up like a small Kubernetes cluster. Getting a lot of little confetti horns there. So I'm using that, and basically all I'm going to do is well, actually, we'll take a look at the somebody's really excited with the little what are those? So the confetti poppers, is that like what that is? I've got this file called evilpod.yaml, so we'll just take a look at that really quickly. This is the same one that I put into this is the same one that I put into the slides for you. So what this is, what we're looking at here is we're specifying what kind of API object this is. So we're going to deploy a pod with this file. This is probably not the stealthiest name to give it, right? Another technique for defense evasion would be to name your resources similarly to how the other resources are named, right? That's not really going to defeat something like, runtime detection stuff, but that is going to, potentially be harder to detect after the fact, right? Looking at logs and things like that, or response to an incident. Then we specify the specification, and we're just specifying what containers to spin up, right? And so the container I'm going to create I'm just naming it evil pod as well. I'm specifying the image to use. So I'm telling it to use Ubuntu. So the cluster will reach out to either, if it's configured to use a private registry, it will reach out to that to try to pull the image unless the image has already been pulled by another container. Again, this is another technique I will use if I need to be stealthy. I will try to do some reconnaissance to figure out what images are already in use by other services, so that I can avoid triggering, the system to reach out to try to pull a new image potentially. And then I'm specifying the command that I want the container to run. And right here is just some of you might be familiar with this, right? A sort of canonical bash reverse shell. Although we do have to pass the actual reverse shell as a command argument to bash itself for this particular version of work. But right, we've got our bash, right? We're piping that into dev/tcp, which is something I use a lot in these kind of container environments, because I'll run into situations where like a base image or a compromised container doesn't have like netcat or something, right, available. I don't necessarily want to install it and trigger, some kind of alert on that. Usage of a package manager is something that gets flagged by a lot of container runtime detection tooling. And a lot of images, right, shouldn't even have a package manager in them in the first place, right? They should be minimal. They should only have the things necessary for their main process to run. So package managers in that base image should be stripped out, so on and so forth. But if there's bash, and they haven't really done any work to kind of configure that version of Bash. Bash has this built-in dev/TCP. There's also dev/UDP, right? These are special things to Bash. And so I can abuse that most of the time to either write like a Bash script to make an HTTP client so I can infiltrate kube control. I've done that. Or just a reverse shell, right? Which again is probably not as very stealthy approach, because I've also found that runtime protection tools tend to do a good job now of detecting what looks like a reverse shell connection. So you have to get a little more crafty if you're conducting a penetration test where, it's a red team engagement, or, you're testing detection capabilities, which is a type of test I get to do sometimes, which is pretty fun. Yeah, so we're going to just tell this to connect out to, my internal IP address and port 555. We're also going to create this with the security context of privileged. This basically is going to dissolve most of the isolation that the container would have. There's a lot of other capabilities we could add. We could say like capabilities all, so we have all the capabilities, but mainly privileged true. It's just giving us additional wiggle room. Volume mounts. This is the old reliable that I kept mentioning, right? So I'm defining a volume mount. I'm saying to mount it under /mount inside of the container. I'm giving it a name, right? I'm just calling it host volume. And then importantly, I'm specifying the mount propagation. This is basically like if you're familiar with running Docker and you do the tac v to bind like a local folder or something into the container, and then you change it and the changes are reflected on the host system as well. That's because by default, Docker tac v does a bidirectional host mount. Here we have to specify the mount propagation, and we specify bidirectional so that our changes to files inside of that mount are reflected to the host system. Realistically, it's not like mirroring the changes. It's just mounting that actual file into the container instead of doing it as a volume where it's replicating the files. And then we actually attach the volume to the container down here under volumes. So we specify the name of our volume mount, and then we want to specify a host path specifically. And the path we're going to specify is the root path of the host. Okay, so now we can jump to doing that, right? So to set this up, what I'm going to do is really quickly, I'm just going to look at, pods, right? We can look at, I've got a bunch of stuff in here, just kicking around. But what I'm going to do is jump over here to this other panel, and I'm going to start my netcat listener. So, oops, it should be listening on port 5555. Yes. So that's listening, and we'll see if we catch a reverse shell. So what I'm going to do is I'm going to, I have my evilpod.yaml file here, and I'm going to do kube control apply tac f evilpod.yaml. And when I apply that, right, that's going to tell me that it was created. I can do kube control get pods, and you probably just noticed that we just got a connection to our reverse shell over there. We see this is messy because it's all squished, but you see evilpod is running here. Right. We could do all kinds of stuff like check out its logs, right? I'm actually curious now. Is it outputting logs? No, it's not. Cool. So now we'll jump over to this, our reverse shell over here. And so this looks like, right, really any other shell that you would get if you attached to a container in the cluster. We've got the host name of the container here. We are root inside this container. And if we ls, right, this is just, we're just running inside of this file system here is just our container images file system, right? But if you remember, we mounted the host file system into /mount. So if I ls that, right, that's going to look pretty much the same. But what this actually is the root file system of the node that this container is being ran in. So if I just like cd into /mount and look around in here, maybe I can do something like cat etsy /shadow. We do like the canonical little, aha, we got them thing. I mean, there's not much in here because this is, again, I'm just using Rancher desktop to deploy this. There's nothing fancy going on in here. but we could, make a file, or we could just do like echo pwned, into etsy / pwned.txt, right? And then we cat our etsy, slash pwned.txt, and we see, right, we're able to write these files to that host file system. I mean, right, that's sort of it. It feels a little anticlimactic to me at this point because I've done it so many times, but at this point, the ability to write files to the host file system of the node like this is, I mean, the world's our oyster, right? There's so many things we could do to backdoor that node and gain further access to it. And again, that's going to, of course, depend on the nature of the engagement and the scope. I have, most of the time when I get to this point on a penetration test where I'm pen testing a Kubernetes system, I say, hey, I reach out to the client, hey, I broke out and compromised one of the nodes, but do you want us to see like how much further we could go, right? Because there's a whole level of like hardening the nodes themselves too, right? So most of the time, right, my clients are interested in seeing that, right? How far can we go? I would say in my experience too, not to I guess plug any particular product, but in my experience, GKE, the Google Kubernetes engine, is the hardest one to kind of pivot from this point because they have gvisor, which is virtualizing. If that's enabled on the nodes, gvisor itself is like a whole nother layer of isolation that's essentially virtualizing Linux system calls and really restricting the set of available system calls. So for example, I was working in that situation. I tried to load a malicious kernel module that was a reverse shell, and it failed because the system calls to actually load a kernel module are not implemented by gvisor, so it just fails out. So, and then they also have their container optimized OS, which has some hardening in place for running container workloads. But yeah, so one thing I've done in the past too here when I've got write access to the host node's file system is just figured out whether whether or not like SSH is running on it, and then I'll just modify like the root user's authorized keys file with my own public key. So now I have SSH access to that node itself. Quick little I guess I don't have full terminal control here, so I can't clear this. But if you're familiar with just like Linux in general, that you can often look under /proc, right? It's /proc/ some PID, and there's a bunch of juicy information about what's running on the system there. So one thing I do when I'm running a container on a system like this, and I've mounted that host file system in there, and I'm thinking, how do I pivot? Well, I've mounted that in there, so I get a snapshot of also the host, nodes /proc. We can, I don't know what the first one is, right? So we can see all this information in here. Like I could do cat proc /1 / what is it, status. See a bunch of information about that. What is the other one? There's another good one. It's like command line, I think, or command. They're all juicy and interesting, but yes, command line, right? So I could do something like cat proc /1 / command line, and we can see that that's showing us our reverse shell there. But yeah, lots of good information to be able to. Oh no, that's me. I'm silly. Let's do. We need to do /proc. I was like, why is that showing me my containers? My containers command instead of like the host nodes. Since I'm in mount here, I need to do / or just do /mount /proc /1 / I don't know, command line, right? And so we'll see there's probably not a process then with like PID1 that's running or something of that nature. But again, the point is you can dig into that and see from this perspective what processes are running on the host system. Just, as a technique I use to kind of figure out how I'm going to pivot. Okay, I'm going to jump back to my slide deck. And yeah, also in here, I included a couple little tools and resources. Some of these are geared towards like securing a cluster, hardening one. But that is useful information to know even right from an attacker perspective too. Right. Link to the other courses I teach, through anti-siphon. I've got 3 of them, right? The one that's coming up soonest is the Kubernetes under siege. We're going to look at pen testing a Kubernetes cluster itself. I also have one where we're going to harden a Kubernetes cluster. And I'm not sure when we'll run this one again, but the out of the box one, this is just one where we look specifically at the kind of deep dive in the mechanisms for escaping containers themselves, right? Irrespective of the context of like Kubernetes. Yeah, some scanning tools, things like that. Yeah, so that's it. That's a whirlwind tour of attacking Kubernetes. Guess I can stop sharing my screen now.
Yeah, you can. Welcome back.
Yeah.
Well, I'm back. You're
back.
still here.
I'm going to end that slideshow.
I was just eating lunch and drinking a frozen protein shake. So.
Delicious.
Mm-hmm.
What did you have for lunch?
I had ground beef with refried beans and like beef stock.
Yeah.
My own soup. Back to soup.
Back to soup.
Soup weather. Cory, thank you so much for sharing that. We got time for a couple questions. So if you have questions, go ahead and drop it into Zoom questions. So that way I know it wasn't answered at some point during the webcast. Sometimes people ask questions and then Cory, you just inherently answer it because you're going to cover it. Here's one. And for Kubernetes vuln scanning is a good tool sysdig.
So sysdig, I've seen a lot about sysdig. I haven't used their tool personally, but I will say that a lot of the times, like when I'm going and researching attack vectors and just to stay up to date on stuff, like sysdig themselves are always putting out like blog posts on really interesting information, right? Related to that. So, I mean, it stands to reason that their tool might be pretty good for vuln scanning in that case, but I can't speak to it having personal experience with it.
Yep. Can you recommend any book to learn about security for containers and Kubernetes?
There's 2 books. I'm going to blank on the names of them. There is one called, and I might just have to drop these in the chat afterwards when I go look at my Kindle, remember what the names are. But there's one, it's Container Security, I think, by Liz Rice. Let me look it up. Yeah, Liz Rice, I think, is one of them. Wait, where is it? Come on, Google, don't fail me now. Yeah, yes. So there's a book called Container Security, authored by Liz Rice. If you're not familiar with Liz Rice, she's very smart, especially about container stuff. So that's a great one. There's another one that I read, which was Attacking Kubernetes, I think is what it was called. I'll get the link to that as well. And the author of that. It's another good one, right? In terms of books, goes through a lot of interesting stuff.
Is it possible to specify an OS version in Kubernetes, or will it only go to latest official?
Do you mean with like the container or the Kubernetes version itself?
The Kubernetes version.
Okay. Yeah, so I mean, you can deploy Kubernetes on different versions. Most of the time with like the cloud hosted versions, by default, that's just going to like auto upgrade to whatever latest version that they want to run the nodes on. Kubernetes itself, like the API service and all of that, you can you're gonna, right, exactly. It's pretty much managed however you're gonna, want to run any other Linux install, right? So you go choose your version of the binary and do all your stuff to set it up and etc.
Yeah. So we didn't get a chance to answer all the questions in the time that we had. So what I'll do is I'll send you the questions that we did get in case you want to like think about a future webcast or a future cast that you'd like to do.
Yeah.
A couple of things to just do housekeeping. Cory, are you teaching anytime soon?
Yeah. October sometime. I'm sorry. I'm
just
terrible
posted
with dates.
the link.
Perfect, because I'm terrible with dates.
So if you thought Cory did a great job of teaching you and helping you learn, you can always take a class with Cory. If you want multiple training things for your organization, then you can contact Kyle. He's here, right? If you go to the anti-training.com website, you can say, hey, I'd like to talk to Kyle, and then you can talk to Kyle. We appreciate you being here. You show up because we show up. We show up because you show up. If it wasn't for you all coming here, we probably had stopped doing this. But since there's over 500 of you here right now, then apparently there's something out there that we can teach and help share our knowledge. Cory, last question for you before we wrap up. Why do you like to teach?
It's just fun to share knowledge that I find interesting, and it's always really teaching's stressful and difficult, but it's pretty rewarding to see people like get excited about something and then go off. And also a lot of times my students teach me stuff too, right? Mm-hmm. They'll ask me great questions that I never thought of, or tell me like a cool tip or trick that I didn't know. I love that. Yeah. So, yep.
Well, thank you all for joining us today. We'll see you next time on an Anti-Siphon Anti-Cast. And that's it. Ryan, go ahead and kill it with fire, sir. Kill it, Ryan.